This is General Vision Booklet 7, higher tier numeracy style questions. You can use a calculator for this paper. Question 1. Orienteering is a competition that involves running and using a compass to find directions. It is usually held in wooded and hilly areas across the country. Liam and Krista are competing in an orienteering event. Liam starts at point A, Krista starts at point B. They are only given the finish point P, the race of the race once they're at the starting positions. Liam is told that point P is on a bearing of 108 from A, and Krista is told that point P is on a bearing of 230. Now this is going to be hard to do on my iPad, but I'll give it my best shot. So Liam is told that point P is on a bearing of 108 from A. So starting at A, put your protractor here. So if you've got a whole protractor, that's fine, just put the middle point here. If you've got half one, you're going to want it to look, oh gosh, that's horrible. You're going to want it to look something like that. So I did this on the booklet, and I think it was roughly, use a ruler, roughly along that line there. Krista is told that point P is on a bearing of 230 from point B. If you only have half a protractor, you're going to want it facing this way. But because you've already gone 180, take 180 from 230 and left with 50. So just go across to 50. And draw your straight line. And they cross around there somewhere. It's not going to be as accurate as yours because I've obviously got my iPad. And make sure you mark it with a point P. When training together, Liam and Krista have the same running speed. Neither of them stopped during the race. Both went as fast as they could and there were no injuries. Both started at the same time. Give a possible reason why the person who started furthest away from point P got there first. Well, they did say at the top that it's held in wooded and hilly areas, so the person furthest away could have less hills. So, no hills, but the person closer could have lots of hills, and that would take you a lot longer. Question 2. You'll be assessing the quality of written communication is question. Shop sells oranges in packs of 8 at a price of £1.44. Special offer is advertised as 2 packs for £2.40. Amir bought 2 packs using the special offer. So he bought these 2 for £2.40. He had to throw away a quarter of the oranges he brought because they became mouldy before he had to eat them. Calculate the price per orange, firstly when buying a single pack, secondly when buying 2 packs at a special offer, and thirdly for the oranges that he actually used, and comment on whether it was wise for him to use a special offer. So for the first one, price of a single pack, so you've got 8 oranges for £1.44, so you just need to do £1.44 divided by 8 to find out the cost per orange. So they are 18p each. For the second one, you get 2 packs, so that's 2 lots of 8, that's 16. So you just need to do £2.40 divided by 16 to get 15p each. So it's best if you use the second price, buy the 2 packs. But if he's not going to use them all, actually, he's wasted some, didn't he? So he had to throw away a quarter. So there was 16, so a quarter of 16 is 4, just divided by 4. You could do that on your calculator. So he only used 12, and it still cost him £2.40. So to find out how much they each cost, we're going to do £2.40 divided by the 12 he only used, which is 20 pence. So it's actually a bit of a waste of money. So he shouldn't have used the special offer, as they're now worth 20p. Due to the waste of 4. So you could write there in the conclusion that he shouldn't have, the price per orange increases because he had to throw some away. But maybe he didn't know he had to throw them away, so it's all about, But money-wise, they were more expensive. Okay, so a cyclist used an app on his mobile phone to record the distance he cycled and the calories that he burnt on each of his last 6 rides. So we've got to draw a scatter diagram, haven't we? So this is just about plotting points. So the first one is 60 and 2,100. So 2,000, I think each 2 is 100, isn't it? 1, 2, 3, 4, 5, yeah. So 60 is obviously there, but 2,100 is going to be here. Because each one, they're going up in 50s on the side. What's the next one? 28 and 1,500. So 20. Sorry, that's my door. So that's 30. So they're going up in twos on the side. So what was it? 20, 28. So that's 2, 4, 6, 8. So that's going to be there. Next one, 86. So it's 2, 4, 6. And 3,500. 3,000, so 2, 4, 6. Try and be as accurate as possible. 52. So 2. So 50 is going to be what's the bottom number? 2,500. So that's going to be there. 24. So again, each one is going across 2 on the bottom. So it's going to come off 2 squares from 20, and 800 is going to be, each one was 50, wasn't it? So 600, 700, 800 is about there. Ooh. 76 and 3,000. So 76, 2, 4, 6, 3,000. Well, if it's to ask us to say the type of correlation, you can see that's going up, so that's positive. I did all those, didn't I? Yep. What type of correlation is shown in the scatter diagram? Well, it's positive. Give a possible reason why the cyclist burned fewer calories on the 60-mile ride than he did on the 52-mile ride. Well, like in the previous question, there could have been less hills, because you're obviously going to burn more energy if you're going inclined. Or you could have just been going slower. Like, if you're going to go really, really fast, you're going to burn more calories because your heart rate is going quicker. But if you take it nice and slow, you're going to burn less calories. So anything along those lines. Next one. Jamal has a number of 3 kilogram bags of potatoes and a different number of 8 kilogram bags of potatoes. The mean weight of the bag of potatoes is 6 kilograms. What's the least number of 3 kilogram bags and 8 kilogram bags of potato? I would do this in maybe like a trial and error, because it's only 2 marks. You could, I don't think, you could try and do it algebraically, but I think just a trial it and an improvement one. So the mean weight of the bags is 6, so that means they've got to add up to a multiple of 6. So you've got to add up to 6, 18, 24, 30, 36, 42, etc, etc, etc. So I would just use different combinations of 3s and 8s and see if you can make one of these numbers here. So obviously if you had 3, 1 bag and 1 bag, 3 and 8 is 11, so it can't be 6. If you could have 8 and 2 bags, that's 6, that wouldn't make 18. You just gotta keep going. Maybe 6, 3 lots of 8 is 24, and 6, that makes 30. So that can be one. I don't think they could go lower because you've got 2 bags, 16, 16 and 3 is 19, so that wouldn't be one. 18 can't be one. 2 lots of 8 is 16, 3 lots of 3 is a 9, 27, it's not going to go 20, I think that's going to be the lowest. So that's 2 lots of 3 kilogram bags and 3 lots of 8 kilogram bags. That's quite low numbers. I don't think that there could be any more. Because 3 lots of 3 kilograms is 9. No, you're not going to get anything better than that. But yeah, use trial and improvement. It might have taken you a bit longer, but for 2 marks, that's not a lot. It's a lot of work for 2 marks, actually. Question 5. A survey was carried out in a school canteen. 90 students were asked which type of cold drink they had selected with their lunch. The bar chart shows the results of the survey. So we got milkshake, water, juice, and no drink. So use the information bar chart to complete the pie chart. One sector has been drawn for you. So to work out these, you want to do how many they go up by. So for example, water goes up to 30. There's a total of 90, so 30 divided by 90 is obviously a third, and then times up by 360, because there's 360 degrees on a circle. So for water, I'm going to do my work down at the bottom, it goes up to 30, so there's 30 people out of the 90 who want water. Let's keep that as a fraction. And to find out what degrees that is times that by 360 degrees. So that's going to be about 120 degrees. I'll try and estimate it. That's probably not 120, but oh well. Next one is juice. So how many people like juice? 35. Still out of 90 people. Times that by still 360, because it's still 360 degrees. Around a point, and that's 140. As soon as we've done this one, we don't really need to work out the next one, but I will anyway. So no drink is 10 out of the 90 times by 360 gives us 40. So that should be roughly 40 degrees. Don't worry if it's like 39, that's fine. Question 6, we've got Amir again. Drove to his sister's, who lives 240 miles away from him. He set out at 9 a.m, travelling the first 110 miles at an average speed of 50 miles per hour. After travelling 110 miles, he stopped for a break. At 12 p.m, he continued on his way, arriving at his sister's house at 3 p.m. Use the information above to draw a distance time graph. Ooh, we're going to draw one. Okay. Calculate the average speed in miles per hour. Alright, we just got to do distance over time for that one. So he drove to his sister's house, who lives 240 miles away. So we've got to end on 240 when we stop. He set out at 9 a.m, travelling the first 110 miles at average speed of 50. So we've obviously got 50. He starts at 9, ends at 100. Oh, those are miles. Oh, sorry. We gotta go to 110. So he's 110 miles away. So each one is 10. 110 is there. And he went at an average speed of 50 miles per hour. So for every hour, get your ruler, and you want from 9 till 10, he's obviously gone 50 miles in that 1 hour. So that's the steepness, well, that's the angle that you want to keep your ruler at. So in another hour, he went another 50, because it's 50 miles in 1 hour. So he's gone 100 miles in 2 hours. You want to keep that in the same and just stop it at 110. Okay, so that should be a nice straight line going 1 hour in 50 miles. He then stops, doesn't he? For how long? He stopped for a break. At 12 p.m. he continued. Okay, so we stop until 12. So here's 12. So we just straight line. He's not going any further away, any further closer. So we got to stop at 12 there. And he arrives at his sister's house at 3 p.m. So this obviously doesn't say what speed he's doing, but we know her house is 240 miles. So at 3 o'clock, you can go up to 240, so each one is 5, so 10, 20, 30, 40. So we just, from here, 3 o'clock, join it to the end of our line. That was pretty decent on my iPad. And there we have the distance time graph. So calculate the Emil's average speed in miles per hour between 9 and 3. Oh, we could have done that really without drawing our distance time graph. So if you didn't do the top bit, you don't necessarily need the top bit to do this, because we know speed is distance over time. So he travelled 240 miles, that's how far his sister is away, and from 9 till 3 is obviously 6 hours. So 240 divided by 6 is 40 miles per hour. So you didn't need that top bit of information to do the bottom bit. Okay, question 7. You've assessed on the written... I don't think I did the OCW bit for the last question. That was OCW. Oh dear. A rectangular area shown below is covered in concrete. A fence is to be put up around all 4 sides. The fence is to be held in place by 26 posts. Use the following information to calculate the total cost for the materials needed for his work. Costing concrete is £8 per square metre for the depth needed. The cost of the fence is £5 per metre. The posts are £10 each. So the first thing we're going to need to do is calculate the area of the rectangle to see how much concrete they're going to need. So area of rectangle is base times height. So we've got 24 metres times 15 metres. So that's 360 metres squared. So that will give us our concrete. The cost of the fence is £5 per metre. So you're going to need the perimeter for that. So I'm just going to work out the perimeter as well. Perimeter of our rectangle. Just need to add up all the sides. So we've got 2 lots of 24 metres and 15 meters, which is 78 meters. And so we use that information for the cost of concrete and fence. So the cost of our concrete, because it's £8 per metre squared, so £8 for 1 metre, we've got 360 metres squared of them. So that's going to cost 2,880. Our cost of our fence, that doesn't look like fence, but oh well, is £5 per metre, so £5 for every metre. We've got 78 of them, so that's a cost of £390. The cost of the posts, we've got there £10 each, and we've got 26 posts, so that is £260. Total cost, pretty straightforward question actually. That doesn't say total. I combine total and cost then. Total cost is going to be 2,880, add 390, add 260, which is 3,530. That, if you can see on the bottom, is off a foundation question, so you should 100% be able to do that question. Okay, question 8. A sprinter covers 100 metres in 10 seconds. Calculates average speed in miles per hour. Okay, so we're going miles to metres. Now the miles to kilometres conversion, we've got 5 miles is 8 kilometres. A good way to remember that is the word miles has 8 letters in. So 5 to 8 kilometres. If we were doing it to 1 kilometre, because we're obviously going into metres, we would obviously just divide those, so that's 0.625. So 0.625 miles in 1 kilometre. So if he's going 100 metres in 10 seconds, we need to put this one into miles and this one into hours. So I'm going to first change the one side into miles first, and then change the other side into hours. So 100 metres is going to be 0.1 kilometres, because there's 1,000 metres in 1, so just divide that by 1,000 here. So still in 10 seconds. So we're in kilometres now. So if it's 0.1 kilometre, and we know 1 kilometre is 0.625, we know that's 0.0625 miles in 10 seconds still. So I've got it in miles, now I just need it in hours. So I'm going to go seconds to minutes, minutes to hours. You can jump if you want, but we've got lots of space, so I wouldn't rush myself. So obviously there's 60 seconds in a minute, so we're going to times that by 60, so we've got 0.375 miles. I shouldn't put m because that's like meters really, isn't it? So that's in 1 minute, and then obviously there is 60 minutes in an hour, so that is going to be 22.5 miles. So calculate his average speed in miles per hour, so he does 22.5 miles. So 100 metres in 10 seconds is the same as 22.5 miles in an hour. Okay, question 9. Catherine has a stall at a charity event to raise money for 2 local charities. Catherine made a fruit juice, the drink to sell at her store. I feel like we've done a similar... Oh no, this is not. She started by thoroughly mixing 200 millilitres of lime juice, 300 millilitres of cranberry juice, and she drank 100 millilitres of mixture to test its taste and decided it was too bitter. She then mixed in 400 millilitres of lemonade and decided that she was happy with the new mixture. Write down the ratio of lime juice to cranberry juice. Write down the ratio of lime juice to cranberry juice to lemonade for Catherine's new fruit juice drink. Okay, so she's got, to start with, before she adds the lemonade, she's got 200 millilitres of lime and she's got 300 millilitres of cranberry juice. That's 500 millilitres. Okay, now she's taken out 100, so she's left with 400 millilitres of liquids. Now, to work out how much lime and cranberry juice, this is just going to be like an estimate, because we couldn't actually say. She could have had all the cranberry juice depending on how well she mixed things. But because she had 400 out of the 500, and it was originally 200 millilitres, we can say that she's got about 160 left of lime. So 400 out of the original 500, and the cranberry juice was 300 millilitres, so she's got about 240 cranberry juice left. And then she obviously adds 400 millilitres, I put millilitres in all this, of lemonade. So there's our ratio, but we need that in its simplest form, do we? Technically it hasn't asked it, but we'll simplify it anyway. So 160 lime, 240 cranberry, 400 lemonade. And I haven't checked the scheme of work, but you probably get full marks just for having that. In its simplest form it's 2, 3, 5, because 80 goes into all of them, divided by 80. Catherine made a profit of £84.80 from selling her fruit juice drink at the charity event. She decided to share the money between the charities in the ratio of 5 to 3. Calculate the amount of money she gave to each of the 2 charities. So this is just sharing in a ratio. So we've got 5 to 3. First step 1 is to add your ratio, so 5 add 3 is 8. Step 2 is to take your amount and divide it by that sum. So that means each one share would be £10.60. So one part is £10.60. You're sharing it in 5 and 3. So you want to times it by 5, times it by 3. So £10.60 times 5 and £10.60 times 3, which is £53 and £31.80. Check that they add up to £84.80, so you've done it correctly. Okay, question 10. Rena plans to make a garden pond. It will be the same shape as a circle. She's brought 10 metres of edging to place around the circumference of the pond. The pond has a diameter that is a multiple of 0.9 metres. She decides to make the largest pond she can with the edging that she's brought. What length of edging will she have left over? Give your answer in metres corrected to decimal places. So we're going to need, we're just doing circumference. So we should know that the circumference is pi times our diameter, and the circumference has to be, she brought 10 metres of edging, so it's got to be 10, hasn't it? Circumference has got to be less than 10. So the diameter has to be a multiple of 9, so it can either be 0.9, 1.8, just 9 times table with decimal in basically, 2.7, 3.6, 4.5. I would just do a little bit of trial and improvement now, so we've got to get a number that's less than 10. So we're going to start with 0.9. Pi times 0.9 gives me 2.83. That can't be it. So the diameter is not that one. Pi times 1.8, 5.65, so it's not that one. Well, it could be actually, couldn't it? Shouldn't really put across 5.65, so it could be that one. Could be that one as well, but it's not using the most, is it? She wants to make the largest possible pond, so we want the number closest to 10 but less than. Pi times 2.7 is 8.48, so it could be that one. Pi times 3.6 is 11.31, so it can't be that, so it can't be more than 10. But the number less than is this one, so it's going to have to be 8.48. So she decides to make the largest possible pond. We've done that because she can't go any more because that's 11.31 metres. She's only got 10. What length will she have left over? So she had 10 metres. She's used 8.48 metres. That leaves her with 1.52 metres left over. Okay, question 11. Builders use cement and sand to make mortars when building walls. They estimate how much material they need to order before they start to work. When useful estimation they use is shown below. So for every 1 metre squares of wall, the cement required is 15.5 kilograms and the sand required is 56 kilograms. Hassan is building a wall 25 metres long. So it goes 25 metres long and 2 meters high. You buy cement in 25 kilogram bags costing £4.87 per bag, and you buy sand in 40 kilogram bags costing £2.65 per bag. Calculate the cost of the cement and sand required. You must show all your work. Is this an OCW? No. Okay, so I'm first of all going to do the area just to see how much cement and sand we need to do. So you should know the area is base times height. So we need 50 meters squared. So for every one, we need this much cement and this much sand. So now we're going to see how much cement we need. So for every one is 15. So we've got 50 meters. So we just got times that by 15.5 kilograms, which is 775 kilograms. The sand that we need. So for every one, it is 56 kilograms. So just do 50 times 56, which is 2,800 kilograms. So cement in 25 kilogram bags. We'll see how many bags we need. Cement bags. So we need 775 kilograms. They're only sold in 25 kilogram bags. So we need 31 bags. So the cost is going to be 31, and they are £4.87 each. So times that by £4.87, and we get £150.97. That's how much the cement is going to cost. Sand bags. So we need 2,800 kilograms, and they are sold in bags of 40. So we divide that by 40 kilograms. That gives us 70 bags. Luckily these are whole numbers. Otherwise, if it wasn't a whole number and it comes to 70.6, you obviously need 71 bags. Or 70.2 would obviously still go to 71. So the cost, they are 70 bags times £2.65 each, which is £185.50. So that's how much the sand is. Our total cost is just to add those up. So we've got 150.97 and 185.50, which gives us £336.47. So that's how much it's going to cost him to building a wall, isn't it? Okay, question 12. They've got a sale, 45% off, now only £451. What was the original price of the sofa? What was the original price of the sofa being advertised? So the sofa was 100%. And then we take off 45%. So that leaves us with 55%. So 55% is £451. So all you need to do is divide those two to get the original amount. So do 451 divided by 55%. You can use 55%, you should know what the percentage button is, or you could do 0.55, and you should get £820. So the sofa was originally £820. You can check that by finding 45% and taking it off. You should still get £451. Look at it, makes sense. You're almost taking off 50%. It's almost halved. Second part, the following deadline is seen in a financial paper. Dehun Limited announces share price of £48, up a third on last year's price. What was the share price last year? So it's got in a fraction, so I'll keep it in a fraction because obviously a third is a horrible decimal and a horrible percentage. So obviously 1 whole is 1, and it went up a third. So 1 and a third, 1 plus a third is 1 and a third. So £48 is 1 and a third. Same principles as above. All you need to do is divide that. So if you do 48 divided by 1 and a third, you get your answer. Now obviously you want to go lower because it was up from last year. So £48 divided by 1 and a third is £36, which makes sense because it's a lower price. If you find a third of 36, well, a third of 36 is 12, add on 12, 48. So we know that's correct. At the start of the football season, a coach recorded the times taken by 40 players in his squad to carry out fitness drill. He grouped the times taken by the 40 players and drew the cumulative frequency diagram shown below. So cumulative frequency, you're obviously going to be looking at mean, interquartile range, etc. So we've got cumulative frequency, goes up to 40. What was the median? So if it goes up to 40, median is obviously going to be halfway. Half of 40 is 20. So go across from 20, read down, and I got around 46.8, because they're decimals. Obviously 47 is going to be halfway. It might be closer to 46.8. Oh no, because my iPad is a bit weird. The coach sets a target over the next week to get the median time of the fitness drill down to 46 seconds. How many need to improve their times to 46 seconds or under, so the median would be 46 seconds? Well, half of, obviously the median, half of 40 is 20. So he wants the 20 person to be, well, it's got to be 20 really. Half of 40 is 20. Where does 20 already go? So one player who took more than, of the players who took more than 46 seconds, how many need to improve their times? Oh, okay, I got a bit confused now. So go up from 46, I was wondering where I had to go up from. Let's go up from 46, read across, but they've got to add up to 20. So see how many need to go across. Oh, I've got my ruler on. So that goes to 8, each one is 1. So of the players who took more than 48 seconds, how many need to improve their times to 46 seconds or under, so the medium time would be 46. Because you want to go, basically, you want to go across at 20 and go down, and it wants to be on 46. So how many from 8 to 20? There's 12. So 12 players, because 8 add 12 is obviously 20. So 12 players need to improve their time, because you want to go across from 20, read down, and it wants to be 46. If you, from 46 is at 8, so these 12, it needs to go up by 12 people. Okay, you'll be assessed on the quality of your written communication in this question. A company has challenged each of its salesperson to show an increase in their sales total each year. The increase should be at least 6% of their sales total for the previous year. In 2013, both Mrs. Farah and Mr. Price had a sales total of £18,000. For their sales total for 2013, 14, 15 were as follows. Write a short note, no more than 3 lines, of each of these 2 salespersons to inform them of how well or otherwise they have met the challenge given to them each year. You must show all the calculations necessary to support your notes. Okay, so we basically want to work out the percentage change that these have changed. So for Mrs. Farah, from 18,000 to 22,000, what percentage has that increased by? So to work out your percentage change, you take your change, so the difference in the 2 prices, and divide it by the original. So divided by the top number. So for Ms. Farah, so from 2013 to 2014, she got 22,000 and 18,000. So take those 2 away. It doesn't matter which way you do it. Don't put a minus. It just wants the change. It just wants the difference in the numbers. Over the original, which is 18,000. So that gives her 22%. So she smashed it first year. So they need it to be at least 6%. So in her first year, she was 22. Let's see how she did it in her second year. So from 2014 to 2015, so she only went up £1,000. Over the original 22, it's not going to be a big percentage, is it 5? So I think she overcompensated in the first year. Maybe you want to put that in your paragraph. So let's do, so she went up 5%. Let's see what Mr. P did. So 2013, you went from 18,000 to 20,000, so that's a difference of 2,000 over the original 18,000. That is 11%. Oh, I've run out of room. Okay, so he's also smashed it first year, almost double. That's quite good. Let's see if he maintained it. So from 20,000 in the second year to 21.5. Did a bit better than hers, probably higher than 5, might just be 6. 20,000. That's 7.5%. So, I mean, it's only an extra £500 better than she did, but I don't know. I'd probably say for Mrs. Farah, she overcompensated in the first year, so she smashed it. She got 22% in her first year, but that had repercussions in her second year, so she only had 5%. Use your figures, use your numbers. So mention 22%, mention 5%. And then for Mr. Price, I'd say he was more consistent, so he met his target each year, even though there was a 11% and then a 7.5%. They both still decreased. So I'd mention something like that. So the following box and whisker plots illustrate the daily rainfall for April 2016 in Trefwen and in Norbury. So rainfall. Okay. Complete the following table: the range, median, and interquartile range. Okay, so if I just focus on one first, your range is to take your maximum and your minimum and take them away. So this maximum is on 55 and this one is on 5. 55 take away 5 is 50. Median in the middle. So you're just reading that number here, so that's smack back on 30. And your interquartile range is your upper quartile, take away your lower quartile. So this one is on 45, this one is on 20, so 45 take away 20 is 25. Pretty straightforward to just read one of these. So for the next one, range max, take away our minimum, this is our median, this is our upper quartile, this is our lower quartile. So the range is going to be your max, take away your minimum, so that's 49. Median, obviously where I pointed out where the median was. Interquartile range is your upper quartile, take away your lower quartile, which would be 30. Iona is going on holiday next April. She's hoping for good weather with hardly any rain. She decides to go to Norbury. Give one reason to support Iona's decision. Include values from both there and there. Okay, so you just want, she goes to Norbury, so she goes to this one. Mention your numbers. So you can say it has a lower median and it has a lower range. That was basically what I'd say. I'd mention that top one's range is that, bottom one's range is that. Just you just gotta use your numbers. Sensible sentence will do. Okay, question 16. I swear you said question 18 earlier. Okay. Question 16. A company logo is made up of 3 parts: a square and 2 identical sectors attached to its sides as shown below. So we've got a square and 2 sectors. The logo displayed outside the company's head office has a central square with a side length of 7. Okay, so these are all 7, so that means the radius of that is 7. Perfect. Calculate total area. Okay, straightforward. So obviously the area of the square is going to be 7 times 7 base times height. That's 49 real meters. Yes, meters squared. Sectors. So I'm just going to do them both because your answer is going to be the same. You could do it once and then double it. It's up to you. So obviously area of a circle is pi times our radius squared. So I'm going to do pi times the radius, which is 7 squared. But we've only got a sector. So you want to times it by the fraction of the degrees you have. So I have 37 out of 360. However, I'm going to do them both. So I'm going to do 37 and 37, which is 74. You can do 37 and then just double it at the end. I'm just doubling it a bit sooner, which is 31.64 meters squared, because if you combine them, that's one big sector. So the total area, just adding up those two, you get 80.64 meters squared. So area of a sector of a circle, pi times the radius squared, times the fraction of the angle you have here over 360. Calculate total length of the perimeter. Ooh, lovely. So we've got 7 here and 7 here. This is also 7. This is also 7. So we've got 4 lots of 7, which is 28. Do the easy bit first because otherwise I'll miss it. And then we've got these 2 lengths here. Again, exactly the same as the area. Circumference is pi times the diameter, but you're going to times that by the fraction of the angle, and I'm going to use 74 again, over 360. So pi times the diameter, radius 7, diameter 14, times our fraction, 74, which is 9.04. So the total perimeter is 37.04 meters. Ooh, velocity time graphs. Okay, the velocity time graph for the short car journey starting at t0. Using the coordinates at t0, t20, t40, t60, t80, t100, calculate an estimate for the distance travelled. So to use to calculate distance from a velocity, you'll either be asked for acceleration, which is gradient of a line, or you'll be asked for the distance travelled, which is the area all under that graph. Now that's where you split it up underneath. Now they've told you where to split it up. They want it from t0, t20, so this is going to be one segment. Obviously, that's a curve there. I couldn't work out the area of that shape. You could count all the squares, but that's ridiculous. What we do is we turn that into a shape we can work with, a triangle. This is an estimate, as they have said. Okay. Then we want t40, so we're going to go up here. That is almost a straight line, but I'm still going to add my straight line anyway. That's a trapezium. We're going to go at t60. Again, that's almost a straight line, but I'm still going to make it a trapezium. See how it's like almost? It's an estimate. T80, again, that's not a straight line, but I'm going to make it one. And then that's a lovely straight line for us, so that is a triangle. So we've got A, B, C, D, and E. So we want the area of all those. They're just triangles and trapeziums. You should know how to find the areas of triangles and trapeziums. So if we start with A, area of a triangle is base, or half, base times height. So we want a half. The base is obviously going to be, distance here is 20, and that goes up to 19. Each one is 0.5. So 16, 17, 18, yeah, 19. So that is 190. Area of a trapezium, if I was to draw it this way, okay, it's like a rectangle and a triangle. Would be a length, this would be a length, and this would be a height. It's a half of A plus B times our height. Okay, so you do the top, add the bottom, times it by our height, and then half it. Now if you look here, they are like this. Okay, so this is A over this side, B, height. So we need to do this length, add this length, and times it by our height. So for B, still a half, because that's our rule, is a half A plus B. So we're going to do a half times the first highlighted pink one, which is 19, because we did that from earlier. Oops. Add this length here, so that's 21. And then we're going to times it by this gap here, which is 20. So that's 400. So for C, same trapezium. Well, not the same trapezium, but same rule. So we've got this top length, this height, add this height. So we've got 21. Add, what does that go across? Just 1 from 15, so that's 16. Times 20 again, this gap here, they're all going to be 20 going across at the bottom. So that is 370. So for D, I need to zoom out a bit so I don't have to keep moving. So D, we're going to go this height and this height, so half times 16 plus, what's that one going up to? 18 times 20 again, so this length. That gives me 340, and the last one, E, got a triangle again, which is just half base times height. So half, base is 20, height is 18, oh yes, from previous one, 18, which is 180. Add them all up, and we get the distance travelled, so 1480 meters per second squared. There's always meters per second squared, unless they do a different time zone here, but it's seconds. So 1480. Okay, last one. A and B are two hollow cones. The base radius of cone B is half the base radius of cone A. The height of cone B is twice the height of cone A. Cone A is completely filled with water. Is it ever possible to pour all the water into cone B without it overflowing? You must show workings to justify your answer. Okay, you're going to make up some numbers here. You can use any. But whatever the radius is here on B, A's radius is going to be double it. Whatever the height here is of B, and whatever the height here is of A, it's going to be half of it. So if this height is H, this is going to be 2H. Okay, so make up some numbers for R and H. I'm going to do R is 10 and H is 30. You could have used 5 and 7. It doesn't matter. Okay, you just want to basically input some numbers to see if they equal. What I should have mentioned first is the volume of a cone. You'll be given this in the front of a formula booklet. Obviously you don't have it in this booklet, I know, but quick Google it. Volume of a cone is pi times our radius squared times our height over 3. So we've got pi times the radius squared times the height over 3. I'm just going to input both of those numbers. Okay, so for A, R is 10, so 2R is going to be 20. H is 30, so I've got my height. I've got R is 20, H is 30. For B, I've got R is 10, because there's only 10, and 2H, so that's, oh, not 30, 60, double it. Okay, so I'm going to input both of those numbers into this, where R is 20, R is 10, H is 30, H is 60, and see what I get. So for A, we got pi times, let me zoom out, pi times 20 squared times our height, 30 over 3. I get 4,000 pi. I'm going to leave it in terms of pi just because it'd be easier. You don't have to. I'll put on my calculator and I see what it is. Pi times R is 10 squared times 60 over 30. Let's see what I get here. So pi times 10 squared times 60 over 3 gives me 2,000 pi. They're not the same then. So this is 6283.19 and that's 4,000 pi. That's 1, 2, so they're doubled. So A is obviously going to be more. So if cone A is completely filled, is it ever possible to pour the water? No, it's this doubled, so that won't happen. So you can just put no, put your conclusion if you want to say no, it's doubled, different numbers. Lovely.